All right, so beginning Unit 4, we're going to continue with quadratics. So I'm hoping this first section is pretty quick, a little review from what we were doing when we were graphing. But now we are going to be solving quadratics. And when we're solving, that means we're solving for the points at which the function intersects the x-axis. And if you remember from your test, there's 2 or 3 other names that we use for these points. We can call them the zeros, the roots, or the x-intercepts. And if I'm going too fast, you can pause the video whenever you need to catch up. All right. A sketch of a graph with 2 solutions would be our quadratic crossing the x-axis twice. 1 solution would be our parabola crossing the x-axis 1 time, which would mean that is the vertex on the x-axis. And then no real solutions if it's above or below, just never crossing the x-axis would be examples of no real solutions. Okay, so the first thing we're going to do is we're going to sketch these graphs like we would any quadratics that we've done this year. Most of these are in standard form, so we'll find the axis of symmetry. We'll start on number 3 together. And then make a table and plot a few more points and find where these quadratics cross the x-axis. All right, so these all start the same way. Negative b over 2a, a negative 6 over 2 times 1 gets us a positive 3. And then we want the y-coordinate, so we need to plug that in. Plug that in to get the y-coordinate. 3 squared minus 6 times 3 plus 8. We get 9 minus 18 plus 8, which is a negative 1. So 3, negative 1 is our vertex. We have another point, 8. 8's our y-intercept, so we can go up here at 8, put a point. We can go the same distance on the other side of our axis of symmetry and put another point. So you can kind of see where this graph's going to cross the x-axis. It's going to be pretty close to the vertex. So what we'll do then is we'll make a table and we'll plug in some values on either side of our vertex, which again was at 3, negative 1. And we're going to look for when we get a y value of 0. We want where y equals 0, because that would be where it's crossing the x-axis. Okay, so let's just plug in points to the left and to the right. That should be enough because at 0 we already have this point right here. All right, let's plug them in, see what we get. Let's do the smaller one. Let's plug in 2. 2 squared minus 6 times 2 plus 8. That gets us 4 minus 12 plus 8. And what do you know? That's where we have a y-coordinate of 0. We don't even need to plug in 4. It's the same distance on the other side. We know we're going to get 0. Let's just skip plugging in 1 and 5 because these are the 2 solutions of our graph. They're the 2 zeros. So 2, 0 and 4, 0 are the 2 roots or x-intercepts. Let's put them on here. Sketch our graph. And then another way you can write the solutions, we don't want to write our solutions like this, 2, 4, because that looks like an ordered pair. So instead, we use these brackets, and we can write 2, 4, meaning this quadratic has 2 real solutions at 2 and 4 on our x-axis. All right, let's have you try 2 on your own. Why don't you try number 4 and number 6? You can just pause the video, try these both on your own, and then I'm going to put the solutions up. It's okay if you're getting a decimal for your or rational number for your vertex. Just plug in points on either side. Okay, I'll work these solutions out with you in just a sec. Go ahead. Okay, so for 4, your vertex should have been negative 5.5, positive 2.25. So we can go graph that on here. Positive 2.25. If you want to put the axis of symmetry, you could do that. Vertical line going right through, great. And then in our table, we want to plug in points to the left and to the right of negative 5.5. So I would have just plugged in negative 5, negative 4, negative 6, negative 3. And it wasn't till you plugged in these 2 points where you were going to get, oops, sorry. This should be, let's fix that really quick. Negative 6 and negative 5, negative 4 and negative 7. It wasn't until you plugged in negative 4 or negative 7 where you were going to get y equaling 0. Let's check. Negative 4 squared minus 11 times negative 4 minus 28. This gets us negative 16 plus 44 minus 28. And there you can see the negative 44 and positive 44 cross out, so we get 0 and 0. So the 2 solutions for 4 were negative 4 and negative 7. Okay, similar with 6, the vertex was at negative 1.5 and negative 4.5. I'm going to skip the graphing for now. You could just plot these points with the vertex. I'll show you after this one and just do your quick sketch. So here's negative 1.5, negative 4.5 right here. You make a table, and again, you would have noticed, here's negative 1.5, here's negative 4.5. Maybe you notice there's no C value, and because there's no C value, your y-intercept's at 0, which is also your x-intercept when it's at the origin. So 0, 0 was a solution. You also might have plugged in negative 1 and negative 2, but then going another 1.5 to the left, you are also going to get 0 for negative 3. So these are our 2 solutions, which are at negative 3 and 0. So there's 3 points for your graph. Our 2 solutions for number 6 were negative 3, 0. I just want to show you one more, number 7, because there could be a case where you have no real solutions. So we'll just do this one kind of quickly here. Feel free to follow along. Negative b over 2a. That gets us 4, 8 over negative 2. Negative 8 over negative 2. And then when we plug that in, we get 4, negative 1 for our vertex. So let's go plot that. 4, negative 1. And then this should tell you something. A negative a value means it opens down. So we're never crossing the x-axis. So we would say no real solutions. And that can happen all the time. Just be careful where the vertex is and how you would graph, whether it be up or down with the a value. Okay, there is a quicker way to find these solutions or the roots of a quadratic, and that's by factoring. So that's why we're going to take some time today in class on Friday to really review all of our factoring techniques. There's a poster on the board. Feel free to use that as a guide, but it's similar steps right here. The first thing we always want to do is we always want to look for a greatest common factor. If you look at number 1, 12 and 18, 2 is definitely a factor. I think not 3, not 4. You keep working your way up. The highest one, the next highest one would be 6. So you want to take out your 6. And we're left with our 2k minus 3. You can always check that you factored correctly by multiplying it back in, and that checks out. So that would be your solution. Now you pause the video, try number 3 on your own, go ahead. GCF should have been 7m squared. You're left with 2m to the 4th minus 5m minus 1. Don't forget this minus 1. You need 3 terms when you multiply it back in, and it needs to be negative. Okay, that's always our first step. Second step is, when factoring, always look for a GCF. Okay. Your next way to factor is if you have a polynomial with 3 terms, a trinomial, and the leading coefficient is 1. Okay. Simple question to ask yourself here. You're just looking for factors of C whose sum is B. Remember, C, B, C is the last term, B is the coefficient of the middle term. So for number 5, we're just looking for factors of 45 that sum to 14. The first two terms are both going to be x here because the leading coefficient's 1. And whatever those factors are, those would be our last two terms in these binomials. So for 45, hopefully 9 and 5 come to mind. 9 plus 5 gets us 14. 9 times 5 gets us 45. That checks out. Let's do another one. Let's do C. Factors of negative 48 that add to 2. So because you have the last term being negative, one of these needs to be positive, one needs to be negative. Negative times a positive gets us a negative. Hopefully 8 and negative 6 come to mind. Positive 8 and a negative 6 because 8 minus 6 is positive 2. Always multiply back in if you want to check your work. Try 11 on your own before we move to trinomials where the leading coefficient is something other than 1. Try 11. Don't forget GCF first. Okay, if you need to pause the video and work it out, please do. When we factor out the 2, remember all three terms have a GCF, we're left with k squared minus 8k minus 20. This can still factor. Factors of negative 20 that add up to negative 8. Should have been negative 10 and positive 2. Don't forget the 2 out in front, and you have your factored form. Multiply back in if you want to check your work. Okay, not every time are you going to have a leading coefficient of 1. 1. There are trinomials where the leading coefficient is something other than 1. In this case, you're asking yourself a different question, and there's multiple methods here. I'm going to teach you the X method. You might know the box method, or you might know other methods you've been taught. That's fine. You can use guess and check. I'm going to show you this method. Feel free to use this one. You're looking for factors of A times C now that, or whose sum is B. Because if you wanted to just put x and x, that's not going to get you 2x squared. So instead, we need to look for factors of A times C, 2 times 18. We'll put that up here. This is our A times C. And that we're looking for those factors that sum to B, negative 15. I'm going to help you out here. When the last terms, or when your last term's positive, middle term's negative, you want two negative factors, because a negative times a negative gets you a positive. And here's what we do next. We just replace that middle term, our negative 15x, with these two factors, negative 12x and negative 3x. And then we just group. Parentheses around the first two, parentheses around the last two. This is the same exact trinomial if you combine those like terms. We take GCFs out of the first terms, first two, so that would be 2x, and we're left with x minus 6. Second term, we can take out a negative 3. And I took out a negative because you want the same binomial, and we're left with x minus 6. Now, I know it looks a little funky, but if you had something like 2xy minus 3y, hopefully you notice these both share a y. So you could take that out and you'd be left with y times 2x minus 3. Well, that's the same thing here with these two binomials. That can come out as 1, and then you're left with 2x minus 3. That's your factored form. How could you check? Multiply it back in. 2x squared minus 3x minus 12x, plus 18. Yep, that checks out. That's what you originally started with. All right, let's have you just try one of these on your own, and then we have our last type of polynomial to factor. Why don't you try 17? Go ahead, let's pause the video and work it out. You're looking for factors of negative 126 that sum to negative 5. Go ahead. Okay, it should have been negative 14 and 9. The 6y squared comes down, negative 21 comes down, and the middle term gets replaced with negative 14y and positive 9y. It doesn't matter where they go. And then we group them. We can take out a 2y. We're left with 3y minus 7. We can take out a 3. We're left with 3y minus 7. And our factored form is 2y plus 3 times 3y minus 7. All right, great job. Our last type of factored form is difference of two squares. Might see a lot of perfect squares here because the only way we can factor a binomial, two terms, other than a GCF, is when the first and last terms are perfect squares, like a squared minus b squared. And this can be rewritten as a minus b times a plus b. And you'll see why on the first one, why you end up with just two terms when you FOIL this out. So x squared minus 4, those are two perfect squares with a negative sign, a difference in the middle. This just factors to x minus 2, x plus 2. And if you check your work, x squared plus 2x minus 2x plus 4, hopefully you can see that's why these eliminate and you're just left with x squared plus 4. This is not factorable. This does not factor to x plus 2 times x plus 2. Look what happens. You get x squared plus 2x plus 2x plus 4. Well, now the middle term does not eliminate, so this is not factorable. That would be a sum of two squares, not a difference. Okay, try 25. Don't forget to take the GCF out first. Go ahead. GCF was 2. We're left with 36r to the 6 minus s squared. These are two perfect squares. That factors down to 6r cubed minus s and 6r cubed plus s. Remember, when you multiply terms with the same base, you add the exponents. That's 6r to the 6th, not 6r to the 9th. And there's your factored form. Okay, just need you for 5 more minutes here. Let's put it all together. Now that we reviewed our factoring, we can solve by factoring. Okay, your steps are right here. We always want to get everything on the same side equal to 0. Then we can use our factoring techniques we just talked about. The last thing we're going to do is set each factor to 0 and solve. We want to set it equal to 0 because when it's equal to 0, that's where y equals 0. And remember, we're solving for the x-intercepts, which is where y equals 0. And then we write it in our solution set using brackets. We'll do 2 or 3 here. Look at 1. Only two terms, and it's a sum, so the only way we can factor is if there's a GCF, and there is x. Take it out, we're left with x times x plus 9. Set these both equal to 0 and solve. X equals 0 is already solved. X equals negative 9 is solved. If you plug these back in to check, the equation would be true. Do a quick check with negative 9. That gets us 81 plus 9 times negative 9 equals 0. Yep, that checks out. Right, let's try one more, and then we'll have you do one on your own. Let's try 8 together. Factors of a times c, negative 24. That's sum to 5. I think that would be negative or positive 8 and negative 3. First and last terms come down. Middle terms get replaced with the 8x and the negative 3x. And then we group. We can take out our, not a 3, but a 2x, and we're left with 3x plus 4. Okay, if there's no GCF here, you still need to take something out because you want to get 3x plus 4 again, and you actually want to take out a negative. That way you get positive 3x plus 4, and that can come out as 1. set these both equal to 0. We get x equals -4/3, subtract 4 over and divide by 3, and x equals +1/2. And then just write them in your brackets. Right? You could plug those in and check. You should get 0 in your equation. Or 0 equals 0. All right, last one. Give 10 a try on your own. Remember, get everything on the same side first. Everything on the same side. Go ahead. All right, I would just move the x squared over, and now you're equal to 0. 6x squared plus 8x. You have a GCF. That would be a 2x, and we're left with 3x plus 4. Set these both equal to 0. And solve. We get x equals 0. And we get x equals -4/3. Write them using your brackets. Let's put the negative first. So we're going in ascending order, and there we go. All right, your independent practice is right here. It's down below. These are the notes that we will take in class on Friday. Your independent practice, just be careful. You have some that's graphing, and then you have some that is solving by factoring. So just read what's listed on Schoology. You can start that now in class after you go over your test. If you have any questions, don't hesitate to reach out, or you can use the class Google chat. Thanks.